Hello students, welcome back to the 10th video of this playlist. So this video will be the last video of this playlist since in this video we will be solving the last question of January 2024 Pure Mathematics 2 paper. So let's see what's the question number 10 from this paper is about. Okay. So the concepts behind question number 10, it's from calculus. To be more specific, it's related to integration and also differentiation of your pure mathematics 2 textbook. So in order to be able to solve this question, you should have idea about the chapter number 7, the last two chapters basically, chapter 7 and chapter 8, differentiation and integration of your P2 syllabus. Okay, so let's get started with question number 10. Okay, so right at first you can see a figure. So figure 2 shows a sketch of the curve with equation y equals to half of x squared plus 1458 over square root of x cubed negative 74. X is greater than 0. The point P is the only stationary point on the curve. Okay, so from the figure 2 you can see the point P is the only stationary point of the curve. Fine. Okay, so part A asks here to use calculus to show that the x coordinate of P is 9. So since point P is a stationary point, so you can easily guess out that we need to use differentiation, isn't it? Okay, so let's start. So the equation for y it's given as what? Half of x squared plus 1458. Make the power visible, so it will be x inverse 3 over 2 negative 74. Okay, so dy over dx would be what? Half of x squared is what? X, right? The power will get multiplied with the coefficient, which is half times 2, which is 1, and then we will subtract 1 from the power, and then for the second term 1458 times negative 3 over 2, so you'll get negative 2187 x to the power negative 3 over 2 negative 1, which is negative 5 over 2. So this is dy over dx. Okay, so at point P what we can write, dy over dx equals what? 0. We can write what? Dy over dx equals to 0. So let's equate. Dy is x minus 2187 over square root of x to the power 5 equals what? 0. Okay, so what we can do, multiply both sides by square root of x to the power 5, that is x to the power 5 over 2. So x to the power 5 over 2 plus x, it will give you x to the power 7 over 2. Okay, minus 2187 equals to 0. So x to the power 7 over 2 equals to 2187. So the value of x would be 2187 to the power 2 over 7. This gives you exactly 9. Okay, so at P, what we can write? So at P, x equals to 9. That's what exactly part A of question number 10 has asked for. That's it. Okay, next is part B. The line L passes through the point P and is parallel to the x-axis. We can see on the figure, line L is parallel to the x-axis and it's passing through point P. The region R shown shaded in figure 2 is bounded by the curve line L and the line with equation x equals to 4. Okay, the region R, it is bounded by curve. Okay, it's below the curve. You can see the line L. It's above the line L and it's to the right of the vertical line x equals 4. So part B asks to use algebraic integration to find the exact area of R. So we need to find out the exact area of region R. So let's see the figure. How can we find out the exact area? Look, what we will do at first is that we will integrate the curve from this point P, that is x equals to 9 to 4. Okay, so as we integrate within this definite integral, we will get a whole area under the curve and the x-axis, right? Okay, but this part, it is below the line L, it's not needed, so we will subtract this area from the value we will get from the integral. That's it. So we need the area of region R, right? For part B, for area of region R, at first find out the integration from 4 to 9 of the which equation? What was the equation for the curve? This was half of x squared. Okay, half of x squared. This is half of x squared plus 1458 x inverse 3 over 2 plus 74 dx. Okay, so what would be that value? Okay, let me check whether the equation is correct. This is negative 74. Okay, it should be negative 74. Okay, let's integrate in definite integral. So x cubed in integration, 1 will get added with the power, so x cubed, and then we will use the new power to divide the coefficient. There is half over 3, which will give you 1 over 6 plus. Okay, not plus, we don't know whether it is plus or minus. With the power of x is what? In the second term, this is negative 3 over 2. So x inverse 3, x to the power negative 3 over 2 plus 1, this is x inverse half. So 1458 divide negative half. 1458 divide negative 0.5, that would give you negative 2916. Okay, just add 1 with the power, you will get new power. Use this new power to divide the previous coefficient of x. That's it. And negative 74, that would be just x. Okay, so 9 4. Now just put the values there. So 9 cube over 6, which is 243 over 2. 243 over 2 minus what? 2916 over 3. Square root of 9 is what? 3. So this is 972 minus 74 times 9, which will give you 666. Okay, then minus 4 cube is 64. 64 over 6 is basically 32 over 3. Okay, so minus 32 over 3 plus 2916 over 2. So that will give you 1458. 1458, then plus 74 times 4. 74 times 4 is 296. Now just add, do the summation, you will get the area under the curve, between the curve and the x-axis. Okay, so 243 over 2 minus 972 negative 666, negative 32 over 3 plus 1458 plus 296. So it will give you 1361 1361 over 6. So this is the area between the curve and the x-axis. So area of region what? Region R would be what? The area of region R would be the area under the curve minus the area of this rectangle. So do we know the area of this rectangle? We know the length. What about the height? Height would be the y coordinate of point P. Do we know the y coordinate of point P? It's unknown. Okay. So put x equals to 9. Okay. So area of region R. Okay. Let's put x equals to 9. If you put x equals to 9, what would be the value for y? So y equals to what? Half of x squared. So half of 81. So 81 over 2. 81 over 2 plus 1458. 1458 over square root of 9 cube, which is 3 cube. This is 27. So this is 54 negative 81 over 81 over 2 plus 54 minus 74. So what would be the y value? 81 over 2 plus 54 negative 74. So this is basically 41 over 2. So we got the y coordinate of point P. So the area of region R would be 1361 over 6 minus what? Length is 9 minus 4, which is 5, times 41 over 2. So what would be the area? 1361 over 6 minus 41 times 5 is basically 205 over 2. So this is 373 over what? 373 over 3. This is the value for the area of region what? Region R. 373 over 3 unit squared. That's the area that we found for region R. And that's basically the end of question number 10, and also ending to the ending to this January 2024 Pure Mathematics 2 paper. That's it. Thank you.